Hello, welcome to another review video. This is a review video where we're going over the solutions to the sheet called Smoking Data. It was on CHD mortality and cigarette consumption. The first screen here has a picture of the data. So the explanatory variable is the cigarette consumption. This is how many cigarettes per adult per year. So in the United States, in the year this was collected, there are 3,900 cigarettes per adult for a year. Okay. Then the response variable is CHD mortality. How many deaths per 100,000 as a result of coronary heart disease? Okay. So we're looking for a pattern and maybe come up with a model where if we have the cigarette consumption of a nation, we can approximate how much or what the rate of mortality will be for coronary heart disease. All right, we're going to go through and answer the questions. I have most of the answers already written here, and I'm just going to go through and quickly discuss them. The first part was just about reading the paragraph. CHD stands for coronary heart disease. The goal of U.S. Public health officials, who I think did this research, was to cut cigarette consumption in half in the United States because the cigarette consumption was the highest in the United States. USA had 3,900 cigarettes consumed per adult per year. That was the highest of all the nations in the data set. And USA also had the highest mortality rate. That's the rate of people dying per 100,000. 257 deaths per 100,000 people were due to CHD. It says which country had the lowest cigarette consumption. I forgot to put that there, but it ended up being Norway, I believe. You can just look at the table. And their consumption was at 1,090 cigarettes per adult per year. Okay, now we're going to start looking at the data. This is question number 2. It says describing the data. The association between CHD mortality and cigarette consumption is positive. It's going up. It's fairly linear and moderately strong. It says which variable is explanatory. We have cigarette consumption. So that's on the x-axis, and we're going to use that to help us predict. Whoops, I didn't mean to cross it out. I meant to circle it. We're going to help us use that to predict the response variable, CHD mortality. So cigarette consumption is the explanatory variable. All right, we can enter the data. So after you enter the data and do the linear regression, you get A, B, R, and R squared. For this data, R is 0.73, which backs up the fact that it was kind of moderately strong. And the question is, what is the statistic R used for? Recall that R is a measure of the strength of a linear pattern. So you can calculate R for a nonlinear pattern. It just doesn't really have a meaning. All right, here we go. So we're going to go to modeling the data. Here we are. What is the equation of the line of best fit? Well, that's located down here. And you notice that CHD is the response variable. It has a little hat because we're using this equation to predict the mortality rate. Okay, and it's equal to 15.64 plus 0.06 times consumption, which is the x variable. So if you use y hat and x, that's okay, but be prepared to define the variables. Tell me what y stands for and x stands for. All right, down below this, it asks us to complete the table, and we got these two y values. We just use the equation to make predictions. When x is 1,000, this is what we get for the mortality rate. When x is 3,500, we get this. If we plot those 2 points, which are right here and right here approximately, we can add the line of best fit to the graph. Okay, and so we've taken care of that. So you just need 2 points and plot that satisfy the equation, plot them, draw the line through them, and like I said, you're done. Now, it's important to know why the line of best fit is the best. What makes this line the best? Well, it minimizes the total squared error. Okay, so it's important to know that. And what exactly does that mean? It's the sum of the squares of the residuals. So remember when we had a graph and we have our line and the date and the points are scattered about it? Remember we drew vertical lines to the graph. those are the residuals. And if we square them, we make squares. And those squares are what we're adding up. So it's the squares of the vertical distances from the points to the line. Okay, we already did C, added it to the graph. All right, my favorite country to visit, Statland. I had a cigarette consumption of 2,000 cigarettes per year. Make a prediction. You just plug it into the equation. This is what we get. A little bit more complicated is finding the residual for France. You had to go back to the original table. The actual mortality rate for France was 60. Then we have to find the predicted value for France. If you look back in the table, France's cigarette consumption was 1,410. You have to put that into the equation, and you get the predicted value. So the Y value from the table was the actual mortality rate. When we put the X value into the equation, we get the predicted. Now, subtract those, and you have the residual. So remember, residual is the actual value minus predicted. Sometimes you got to look in the table for the actual value. Sometimes you're going to have to go ahead and use the equation to make a prediction. Okay, if a country has a negative residual, what does that mean? Well, if you kind of think of the formula here, over here, residual is actual minus predicted. If it's negative, it means the actual value was smaller than what was being subtracted. It's smaller than the predicted value. So if the residual is negative, the actual mortality rate for a country was lower than the predicted value. All right, what was the slope? We found it was 0.06. The units would be kind of complicated, but it'd be the y units over the x units. And interpret the slope. Okay, for every additional cigarette consumed, that's the x variable, on average, so remember you need the words on average in here somewhere. On average, I should say not an average, on average, 0.06 more people die of CHD per 100,000 people. So every time the cigarette consumption goes up by 1 for a country, the CHD mortality rate goes up by 0.06. I just kind of included the units. It's 0.06 people per 100,000 people. Okay, so hopefully that's clear. All right, next. It says, suppose a country has a cigarette consumption equal to 6,000 cigarettes per adult. Would it be appropriate to use our regression equation, a regression line to predict the CHD mortality rate? The answer is no. The reason why is 6,000 is outside of the range of our data. There are no x values, if you go back and look in the table, that are anywhere near 6,000. If we kind of go back and look at the graph, we see a 6,000 is way off the graph. It's outside the range of the data. So let me come back here. So 6,000 is outside the range of our data, so we can't use it to make a prediction. When you try to make a prediction that's outside of the range of the data, that's called extrapolation. So that's a no-no in stats. We can only make predictions based on values that are close to the data values we have. Okay, but what if a country has a consumption rate of 3,000 cigarettes per adult? What about that? Would it be appropriate to use our model to predict their CHD mortality rate? Actually, yes. 3,000 is within the range of the data. If you go back to the graph and look at it, it's kind of in the domain. It's between the smallest and largest values of the data. So that's fair game. All right, this brings us to the grand finale here. Actually, this is very important. This question occurs on the quiz a couple times. Find the value of r squared. Okay, I just took r and squared it, or you could also just look in the calculator, it reports it. The value of r squared is usually expressed as a percent. So I said 53.4%, even though the calculator tells me 0.534. And we like it in percent because it's kind of used that way in how we interpret it. It means 53.4% of the variation in CHD mortality is explained by the cigarette consumption. So the CHD mortality was our response variable. This is where understanding the words or vocabulary helps. And and cigarette consumption was the explanatory. Variable. Well, how good was it? How good was the explanatory variable in helping us? By creating the line of best fit and writing an equation that predicts the CHD mortality in terms of cigarette consumption, ended up explaining 53.4% of the variation. So there's some percentage left. So this is a measure of how good the line of best fit does. If it were 100%, then the line of best fit would go through all the data and there'd be no variation about the line left. But here, as we go back and if you look at the line of best fit, there's still quite a bit of scatter about it. Okay, so like I said, a measure of how good the model does. It's the best a straight line can do for this data. Okay, well, if you have further questions, feel free to ask us in class. Good luck on the quiz.